This is Chapter 3 in 5 minutes or less. In Chapter 1, we talked about information being processed data. Business intelligence is data that comes from different sources that is analyzed to help identify patterns, relationships, and trends that may help a business. A business intelligence system, then, is a form of information system, as we discussed in Chapter 1, made up of hardware, software, data, procedures, and people. Data for a BI system is generally stored in a data warehouse, which is somewhat like a huge database. This data warehouse has a BI application that manages the database. It can accept or import new data into the database, modify or delete that data, perform some analyses on the data, and export the data to end users. Business data comes from a variety of sources. For one, it can come from customer service interactions. As customers call in to report problems or as they fill out information on a web form, that data is captured and stored for later use. Data can come from sales reports. Data isn't always specific to a customer. Sometimes sales data includes numbers of items sold, numbers that were defective, or even items that are discontinued and replaced with newer models. Data can come from web traffic. Data can include the number of times a link was clicked or the amount of time a user stayed on a specific page. Data can also come from outside sources. A company might have data from a vendor about different items and prices, or a company may buy demographic data from another source. Sometimes the data that comes into a database isn't reliable or is missing information. For example, if a company gets demographic data from a third party, that data might be missing phone numbers or the addresses may be formatted differently from what is used in their database. That data might spell out state names, but the database might use the two-letter postal abbreviation. One of the functions that a BI system may have is to clean up data and prepare it for use within the main data warehouse. This function is sometimes referred to as ETL, or extract, transform, and load. Pertinent data from a data source is extracted, transformed to match the formatting requirements, and loaded into the data warehouse. Data in a data warehouse is then available to end users of a company. Through their BI applications, users can pull data from the main data warehouse to determine how much raw materials is needed for the next production run based on previous sales data. Or the customer service representatives can see if there are any production delays or part recalls, so they'll know when to expect a flood of calls. Sometimes information in a data warehouse is too vast to the point where searching takes a bit longer than expected. Or a company may decide that not every department needs to access the entire data warehouse. If a department needs only specific data to carry out their business functions, they can work from a data mart instead of the main data warehouse. Information can be presented to end users in several ways. Reporting is a simple way of looking at data historically. There are different means of looking at data, from simple tables to OLAP cubes. Data mining, on the other hand, looks to the future. Data mining applies statistical methods to find patterns and make predictions or find trends. Stock traders and meteorologists would benefit from this tool. Using historical data, stock traders can tell if a company's stock price is going to rise or fall, and meteorologists can use historical data to tell us if there is rain in our future. Finally, big data analysis involves a huge data set. Tracking Twitter trends or Facebook mentions is a huge task for any computer because of the sheer volume of data involved. Big data sets are analyzed using several different techniques, such as MapReduce. Strides have been made in recent years where computers are beginning to process all this data and make decisions and predictions for us without our intervention. Moore's Law, Kreider's Law, and Nielsen's Law all converge to give us some very powerful computer networks that mimic human thought patterns and behavior. This artificial intelligence can be applied to these business intelligence concepts to help automate different business processes. On the lower end, an AI can look at manufacturing and sales data and conclude that a product will be out of stock soon and decide to order more materials and ramp up production. On the higher end, AI can look at a company's past performance and with other factors can decide if it's worth partnering up with them for a project or if it's too risky. There's concern about AI being a complete replacement for humans, and this probably comes from movies such as iRobot and the Terminator series. AI is still a long way off from those scenarios, but for right now, there really shouldn't be a huge worry about robots taking over our lives. The reality is that AI machines are just that, machines. They may replace humans in some capacities, that's a given. Machines can work on a production line for days on end without needing a break or overtime pay. Even way in the past, machines replaced switchboard operators, and people that were displaced from their jobs learned new skills and forged ahead. These machines will still need programmers to help improve their capabilities, and engineers and technicians to make sure they're physically fit for duty. And that's Chapter 3 in 5.